Okay, we're going to look at the different reflections for the greatest integer function, and then we're going to go through an example that has a reflection, and we can work on writing the range of. So I first want to remind you of what our greatest integer function generally looks like. So this is something I have memorized, that I know how this step function looks, that it starts at 0, 0. The steps generally go towards the right, then they go up, and they are 1 unit long and 1 unit apart. And then I'm going to visually do each of these reflections. So how I know what to reflect, when the negative is outside of the function, so we kind of talked about this a little bit more now that we've been covering more about transformations. When that negative is outside the function, remember how your function generally works. If you're plugging stuff into the greatest integer function, the x values are basically the numbers before they are rounded, and the y values are the numbers after they are rounded. Look at where this negative is. This negative is outside of the brackets, which means you would apply it after the number is rounded. So it would be applied to the y value. That means you're changing the sign of the y value. Think about where y's go on the graph. Positive y's are above here, negative y's are down here. If you are changing the y values, positives become negatives, negatives become positives, you'll notice that these points would flip over the x-axis, okay? So when this is here, this is a reflection over the x-axis because I'm changing the y value. And then what that physically is going to look like is, since this first step is on the x-axis, it will stay. But then this second step that was up here, when I reflect it over the x-axis, it would look like this. This third step would look like this. And I would no longer graph those steps of the parent function, just the new transformed steps. So I know that whatever I'm graphing that has this reflection in it has their starting point. The steps still go towards the left. And then however long they are and however far apart they are, they kind of go in this order, kind of descending. Okay. Now I'm going to look at the same thing, but with the negative in a different position. So what happens when the negative is in here? Okay, this would basically be, the negative would be affecting the x before you do the rounding. So it's going to be changing the x values. So think about how x values are set up on a graph. All of the positive x's are on this right side of the graph. The negative x's are on the left. So if you're changing a negative to a positive and a positive to a negative here, you're kind of flipping it from left to right, like the pages of a book. That is a reflection over the y-axis. So changing the x-coordinate actually flips over the y-axis. So again, I would have my visual of how I normally think about this graph, steps that are 1 unit long, 1 unit apart, starting at 0, 0 and ascending like this. And now when I perform that reflection over the y-axis, I see steps that look like this. So I now know, I'm going to cancel out this parent function, I'm not going to graph that wherever my starting point ends up being, I'm going to start at that point, but I'm actually going to draw my steps towards the left, end the step, go up to the next step, and then continue that pattern. Okay, so where the negative is placed tells me it's a reflection over the x or y axis, kind of based on if it's changing the x or y coordinate. So let's put that into practice, and then let's see how we write the range of something like this. So just a small note here, we need to factor out that 1/3, and I get a 3 because -1 divided by 1/3 would leave me with -3. Now, things that I know about this. I have this negative, so that is a reflection. It's outside of the brackets, so it's changing the y, but remember, changing the y here means that we reflect over the x-axis. That 2 is a vertical stretch by 2. So we know that the things are 2 units apart vertically. And the last vertical change we have is the shift up 4. Horizontally, we have 2 things happening here. We have this 1/3, which is going to end up being a horizontal stretch by the reciprocal of 1/3, which is 3. And we have this -3, but really remember that's x minus h, which means the h is actually a +3, and that's going to be a shift right 3. So I'm going to think about first the reflection, because I want to kind of have a roadmap of how to draw my steps. So again, remember the parent function is like this. You had this reflection outside the function, which is reflecting over the x-axis. So you'll still start at the starting point. You'll go to the right and end, but then the steps will look like they're descending instead of ascending. Okay, we won't graph those. So I'm going to follow that pattern. So now I'm going to figure out where is my new starting point since these steps have been shifted. So the shifts I have here are right 3 and up 4. So my new starting point, that HK point, is going to be at 3, 4. So I'm going to go ahead and find the point 3, 4. That's my new starting point. Now I know I draw my step to the left. So the question is, how long do I draw the steps horizontally? So I had a horizontal stretch by 3. So this step is actually going to be 3 units long. So it's going to stretch all the way over to 6. So it started at 3, it went over 3 units to 6. Now I know according to my picture, after I draw that first step, I should go down to the next step. And the steps are 2 units long, or excuse me, 2 units apart vertically, based on what we figured out from our A values. So I'm going to go ahead and go down 2 units. My next step, which would again be 3 units long. Now that I see the pattern, I can fill the steps in and see how they would look. So now to get the range for this, the range is basically the y values I reach, which if I took a small sampling here, I would see that I reach the y value of 2, 4, 6. Okay. The next step would be down at 0. And that equation we are writing is supposed to be an equation that gets people those numbers and only those numbers, so that they can plug in different things and get different values, but they only get values that are here. So the first thing is when they're calculating the y value, we want them to plug things in, different things, so they can get different numbers like we have here. But we need to make sure that whatever they plug in is always 2 units apart, because that's how all of our y values are. So that's where we get this 2k from. This is essentially that A value, that vertical stretch. Then what we need to do is position them at a starting point. If we just put 2 times something, they may or may not end up at the points we're at. They will end up at numbers that are 2 units apart all the time, but not necessarily the numbers we want. So we need to pick one to start. So you need to pick a place that your step exists. I could pick 2, I could pick 4, I could have picked 0 and not had a number there, or 6. So you could use the k value for this because you know that you always have a step at that value. So this is where we're getting this from. We're using our a and our k because we need a point that we're starting at. That's the k value, and we need to know how far they're separated by. That's the a value. And then we need to just make this one statement that k is an integer. That way people aren't plugging in like fractional amounts, and then it wouldn't keep them 2 units spaced apart. So hopefully that helps a little bit with that.